Most people think modern science began with Galileo or Newton, but the real spark was ignited 4 centuries earlier by a man named Robert Grosseteste. In a world dominated by ancient philosophy, Grosseteste dared to ask, how can we prove what we see? He was the first to suggest that the universe operates on mathematical laws, using light itself as the ultimate blueprint. By moving us from why things happen to how they work, he laid the groundwork for the empirical method we still use today. He transformed the medieval mind from passive observer to active investigator. Look at this progression, from a bishop's mitre to the refraction of light to the expansion of the entire cosmos. It seems like a leap, but for Grosseteste, it was a single, logical thread. 800 years before Edwin Hubble observed the galaxies receding, Grosseteste sat in Lincoln, England, and described a universe that began as a burst of light, expanding outward to form the stars. He didn't just guess. He codified the rules of optics and refraction, insisting that nature must follow geometry. He was performing, quote, digital simulations with nothing but parchment and pure logic. He wasn't just a man of his time, he was a man out of time. So how did a 13th century bishop see what the rest of the world wouldn't for another 400 years? Great minds aren't always born into privilege. Robert Grosseteste began with humble roots in Suffolk around 1168, yet he would go on to shape the intellectual foundations of the Western world. By the 1220s, he wasn't just a teacher, he was the first functional chancellor of Oxford University. He mentored the newly arrived Franciscans, teaching them that to understand the Creator, one must first understand the creation through mathematics and light. In 1235, he reached the height of both spiritual and political power as the Bishop of Lincoln. But he remained a scientist at heart, managing the largest diocese in England while continuing to write on the properties of the physical world. When he died at age 85, he didn't just leave behind a diocese, he left a multidisciplinary blueprint that we are still following today. To Robert Grosseteste, light wasn't just something that helped you see, it was the very fabric of reality. He called it luxe, and it was his unified theory of everything. Look at this trinity. First, cosmology. Light provides the physical mass of the universe. Second, optics. Light is the mathematical language nature uses to move and interact. And third, epistemology. He believed that just as physical light reveals the world to our eyes, a spiritual light allows the human intellect to grasp complex truths. It was a bridge between the physical world we measure and the mental world we inhabit. By centering everything on light, Grosseteste created a world that was logical, measurable, and profoundly connected. He made the universe knowable. 700 years before the Big Bang Theory was formulated, Robert Grosseteste described the birth of the universe in 4 precise, logical steps. It begins with a point. In an instant, this light multiplies infinitely in all directions. It doesn't just fill space, it creates space, giving the universe its 3-dimensional volume. But expansion has a limit. When matter reaches its thinnest point, it crystallizes into the firmament. From there, light reflects back inward, pushing imperfect matter into the beautiful concentric spheres of the planets and stars. This wasn't just a myth, it was a mathematical hypothesis. Grosseteste had built a model of the cosmos, using nothing but the physics of light. Can a 13th century theory survive a 21st century supercomputer? Researchers at Durham University decided to find out by translating Grosseteste's Latin into mathematical code. They found that his model relies on a delicate balance of 3 forces: opacity, lumen intensity, and transparency. It's a medieval Goldilocks zone where the math must be exactly right. The results were stunning. When the parameters are perfectly tuned, the simulation produces exactly 9 concentric spheres, just as Grosseteste predicted. If you change them even slightly, the universe collapses or never forms. This proves Grosseteste wasn't just dreaming, he was calculating. He had discovered the fine-tuning of the universe 800 years before we did. Robert Grosseteste believed that to understand the world, you had to speak its language. To him, that language wasn't Latin, it was geometry. In his works on the rainbow and on color, he did something extraordinary. He moved away from simple lists of colors and visualized them in a 3-dimensional space, governed by how light interacts with matter. By charting exactly how light bends through different mediums, he didn't just explain the rainbow, he foresaw the principles of magnification. He was building the theoretical foundation that would later give us the microscope and the telescope. He proved that nature isn't just a collection of objects, it's a system of mathematical laws waiting to be decoded. Before Grosseteste, science was often just armchair philosophy. He changed the game by insisting that a theory is worthless unless it survives the test of reality. His method follows a loop. First, resolutio. You take an observation, like a plant's medicinal effect, and strip it down to its core principles. Then, compositio. You use those principles to build a complete, logical explanation. But here is the first spark of modern science. Step 4. The experimentum. He argued that we must use controlled testing to eliminate false causes. If the experiment fails, the theory dies. It sounds like common sense today, but in the 1200s, it was a revolution. By closing this loop, Grosseteste gave us the tools to not just wonder about nature, but to master its laws. How do we actually know something is true? For Grosseteste, the answer wasn't found in a book, but in the very nature of light itself. He taught that our mental vision is often clouded, a state he called the sick intellect. Just as dust or fog obscures a landscape, our physical nature can distract us from grasping deeper universal laws. The fix is a dual system of illumination. Your physical eyes need the bodily sun to see geometric forms, but your intellect needs a spiritual light to recognize truth. It's a beautiful parallel. Science observes the world, but illumination understands its laws. By merging these two worlds, Grosseteste created a path where faith and physics don't just coexist, they empower each other. Centuries before Georg Cantor formalized the mathematics of infinity, Robert Grosseteste was already grappling with the idea that not all infinities are created equal. He argued that a timeless God could use these unequal infinities as a ruler to measure the vast dimensions and duration of our universe. It was a staggering attempt to bridge the gap between the infinite and the measurable. But he applied this logic to us too. In his theory of liberum arbitrium, or free decision, he argued that because God exists outside of time, our choices remain truly free. Our future isn't a fixed line, it's a series of genuine contingencies. By defining the boundaries of infinity, Grosseteste managed to carve out a space for human freedom in a mathematically ordered cosmos. To understand Robert Grosseteste, we have to look at the whole man, not just the scientist we admire today, but the medieval bishop rooted in the tensions of his own era. On one side, he was a hero of integrity. He famously stood up to both the king and the pope to fight corruption, all while building the empirical framework that would eventually give us modern physics. But there is a darker side to his legacy. Like many in the 13th century, his brilliance was shadowed by rigid dogmatism. He held deep anti-usury views and authored texts that fueled the era's growing anti-Semitism. Grosseteste proves that history is rarely black and white. He was a man of radical light who remained, in some ways, a prisoner of his time. Grosseteste didn't just study laws of physics, he enforced laws of integrity. At age 65, when most medieval men were long retired, he took command of the Diocese of Lincoln. He fought a three-front war for reform. First, the chapter. He demanded the right to inspect his own clergy for quality. Second, the crown. He stood as a shield for the English Church against the financial greed of King Henry III. But his most famous act came in 1253. He flatly refused a direct order from Pope Innocent IV to appoint the Pope's nephew to a high-ranking position, arguing the man was unfit for service. He put the spiritual needs of the poor above the political whims of Rome. In Lincoln, Grosseteste proved that the same analytical rigor he used to map the stars could be used to build a more just and transparent world. To truly understand Grosseteste's impact, we have to look at the world he inherited versus the world he left behind. It was nothing short of a total paradigm shift. Before him, science was qualitative, based on storytelling and unquestioned ancient authorities. Grosseteste demanded more. He replaced "I think" with "I measured," and "it is written" with "I verified." He broke down the walls between the heavens and the earth. By using light as his unified medium, he proved that the same physics governing a rainbow in a garden also dictates the motion of the stars in the deep cosmos. This wasn't just progress, it was a new way of being human. He gave us the keys to a knowable, predictable, and measurable universe. History isn't a series of isolated events, it's an unbroken chain. While Robert Grosseteste was never formally canonized by the Church, his intellectual canonization is undeniable. His light-based physics passed to Roger Bacon, who formalized experimental optics, and then to William of Ockham, who stripped away ancient speculation in favor of empirical evidence. By the time we reach Galileo and Newton, the language of nature as mathematics was already 400 years old. Newton's masterpiece on light and gravity didn't appear out of nowhere. It was the final blooming of a seed planted in Oxford centuries earlier. Grosseteste didn't just live in the Middle Ages, he shaped the modern mind. He was the origin point for the trajectory of Western science. History often moves in cycles of shadow and light. Robert Grosseteste stood at the very edge of that cycle, the final great mind of the medieval tradition and the first of the modern. He didn't just teach at Oxford, he built its soul. He took a world of mystical speculation and replaced it with a world of measurable laws. He proved that the human mind, illuminated by reason, is capable of reaching the furthest edges of the cosmos. The first spark he ignited didn't just flicker and die. It passed through the hands of Bacon, Occam, and Newton, eventually lighting the way for the very technology and telescopes we use today. Robert Grosseteste taught us that to seek the light is to seek the truth. And in that search, he changed our universe forever. He revolutionized inquiry by replacing pure reason with repeatable experimentation and empirical observation. He established light as the fundamental physical form, directly influencing the development of lenses and telescopes. He transformed natural philosophy by applying rigorous quantification and mathematics to explain the cosmic order. He successfully bridged the gap between faith and logic to foster a culture of institutional learning and reform.